Hello, grade 7. Today, inshallah, in our lesson, we are going to talk about finding probability using a list. We talked before how we can use probability by using table, by using tree diagram, and this is the third part, which is finding probability using a list. One way to provide secretary for a locker or personal account, it's to assign it an access code number known only to the owner. Then in this question, we want to know the code. Then we have 3 digits number, which is 1 and 2 and 3. We want to find from these numbers, maybe repeated, find the probability that randomly assigned number is 222. In this type of
assigned number is 222. Well, certainly you know off the top of your head, both of these outcomes here to help us understand that. So the combination for PIN's locker is a 3-digit code that uses the numbers of 1, 2, and 3. Any of these numbers may be repeated. Find the probability that PIN's randomly assigned number is 222. Well, certainly, you know, off the top of your head, there can only be 1, 2.
So in this one, as I said, we want to know randomly assigned a number is 222. But already we said that we have 3 digits. So we will explain how we are going to make a list. So we will imagine that 3 numbers, we will say that each number is a leader for a group. Okay, so we will take 1 as a leader, 2 as a leader, 3 as a leader. For how many, by the end, how many outcomes? We have 3 numbers, and the 3 we will repeat it 3 times. So we can say 3 times 3 times 3. So by the end, we will find that we have 27 outcomes. But how we are going to write the list? As I said, we are going to deal with each number as a leader. Then 1 is a leader for 3 groups. 2 is a leader for the next 3 groups. 3 is a leader for the next 3 groups. Then for the first one, I said 1 is a leader. So you can see in the first group 1, 1, 1, 1, 1, 1, 1, 1, 1. And after that, we will repeat this number 3 times. So we have 1, 1, 1, and then 2, 2, 2, and then 3, 3, 3. After that, we would write them in order 1, 2, 3, and then 1, 2, 3, and then 1, 2, 3. So as I said, we are going to deal with 1 as a leader for the 3 groups. And after that, we will separate each one. We will repeat it in each table. Then 1, I'm going to repeat it in the first table, and then 2, and then 3. By the end, we would write 1, 2, 3, 1, 2, 3, 1, 2, 3. And we will make, again, we will make the same with number 2. How? With number 2, we have 2, 2, 2, and then 2, 2, 2 for all, and then 2, 2, 2. Then first group 1, 1, 1, 2, 2, 2, and then 3, 3, 3. The last digit, it will be 1, 2, 3, 1, 2, 3, 1, 2, 3. Then for the first choice or first trial, when 1 was a leader, we have 9 outcomes. Second, we have 9 outcomes. Third, we have 9 outcomes. So by the end, we would discover that we have 27 outcomes. So I have 9, 9, 9. And as I said, the second group, the leader is 2. Then I will write 2, 2, 2, 2, 2, 2, 2, 2, 2. And after that, we will repeat 1, 1, and then 2, and then 3. Then we will write them in order 1, 2, 3, 1, 2, 3, 1, 2, 3. And we will make the same with 3. The leader for the first one is 3, 3, 3 for all groups. And then 1, 2, 3, and then 1, 2, 3, 1, 2, 3, 1, 2, 3 for each one. Now we are going to look for the key, which was 222. Find the number of outcomes in the sample space by counting all the possible codes. There are 27 such codes. Like I said, in this group we have 9, in this group I have 9, and this group I have 9. So note that there are 3 possible first numbers, 3 possible second numbers, and 3 possible for the third numbers. Then by the end, how we can find the possible outcomes? It will be 3 times 3 times 3. It will be equal 27. Okay. Then how many times did we found 3 numbers? So we said that 3 numbers we found 222. We found it 1 out of 27. Let's move to the next question. Please listen.
Types a 4-digit code into a keypad to unlock the car door. The code uses the numbers 1 and 0. If the digits are selected at random, what's the probability of getting the code of exactly 2 zeros? What I did was I created and started this. So it said a 4-digit keypad. Okay, so here's the 4 positions right there. Okay, and I just started putting in my numbers. So again, they're only using zeros and ones. So the first one I put in is that this could be a combination. And the next one, this could be a combination, and so forth. And you can kind of see there's a pattern here. But I did not finish this. Okay. So the next one after this thing would be 1 0 0 0, and you would continue on until ultimately you would end up with all ones here. So you work on figuring this out. Then the next piece you have to figure out is say, what's the probability of getting the code of exactly 2 zeros? Okay, so if we look, from what I have already done, that's exactly 2 zeros, that's exactly 2 zeros, that's exactly 2 zeros, and you will continue on. So at some point then, you're going to come out with the probability of some number, and I'm just going to call that A, over the total. So you have to work to get the total amount. That's what we did first. And then you have to find all combinations that have exactly 2 zeros and count them up. And then that's what will go here in the A position. The rest of this is guided practice. And then the practice questions, if you have any need help, let me know. Yeah, good day.
Okay. Then this was the part.
8 different possible outcomes. The first thing we need is bread, and we can either have wheat or sourdough. So from this point, we're going to make 2 branches, one for wheat and the other for sourdough. After we choose the bread, we can randomly select ham, turkey, steak, or chicken. So if we chose wheat, we could then extend the branches for each type of sandwich. Ham, turkey, steak, and chicken. And if we chose the sourdough, we would also extend the branches for each type of sandwich, ham, turkey, steak, and chicken. And now we can determine the number of possible outcomes. And we can do this by counting up these branches. And here we can see that we have 8 different possible outcomes. We can have a wheat ham, a wheat turkey, a wheat steak, a wheat chicken, sourdough ham, sourdough turkey, sourdough steak, sourdough chicken. That was a tongue twister. So here's our first try question for this video. What if the sandwich shop added multigrain bread? Draw a tree diagram to find the sandwich space. How many different sandwiches will there be possible now? In our second example, we're going to be finding the sample space to help us determine the total number of possible outcomes. Unlike the last example, instead of a tree diagram, we're going to use a table. So this question says, find the total number of possible outcomes of rolling a number cube, so regular dice, and flipping a coin. So, on the top of the table, we can write the possible outcomes when we roll the dice. So we can have 1, 2, 3, 4, 5, and 6. And on the side, we can write the possible outcomes when we flip a coin. So, heads or tails. And we're going to use H to represent heads and T to represent tails. Now inside the table, we're going to write 1H. And that's going to represent that we roll the 1 and the coin is flipped to heads. And then we'll just continue this. So 2H, 3H, 4H, 5H, and 6H. And then 1T, 2T, 3T, 4T, 5T, and finally 6T. So in this table, we can see that there are 12 possible outcomes, and all the outcomes are found inside the table. Here's our second try question for this video. We want to create a table to find the sample space of the total number of outcomes on a spinning spinner and randomly choosing a number from 1 to 5. Hopefully using the table to find all the possible outcomes was really familiar because we did the exact same thing when we were drawing Punnett squares in science class to determine the genotype of potential offspring if the genotype of two parents were heterozygous for the phenotype of pair, for these infants. So we can see in the Punnett square, it allows us to see the sample space because in the Punnett square, we can see all the possible outcomes. We got big H, so homozygous dominant. We got a big H, little h, so heterozygous. Another big H, little h, so heterozygous again. And then a little h, which tells us that it's homozygous for the recessive alleles. Perhaps you've noticed from the last couple of examples, there's a quick way to determine the total number of possible outcomes. To find the total number of outcomes from event n and event n, which just means two different events, we can multiply the possible outcomes from event n and event n. So for example, with the type of sandwiches and bread, we had 2 possible bread outcomes and 4 possible sandwich types. And 2 times 4 gave us 8, which is why in this example, there were 8 possible outcomes. In the second example, with the coin and the dice has 6 possible outcomes, and the coin has 2 possible outcomes. So 6 times 2 gives us 12, which is why this one had 12 different possible outcomes. In our third example, let's use that quick method that we just talked about to determine the total number of possible outcomes. This question says, how many different outfits can you make from t-shirts, jeans, and shoes in the closet? Remember, compound events can occur from 2 or more events. Since we're looking at 3 different items of clothing, we have 3 different events. So if we look in the closet, we can see that there are 4 different jeans, so there are 4 outcomes. There are 7 different t-shirts, so there are 7 outcomes. And we have 3 different pairs of shoes, so that's 3 outcomes. Now we can multiply the possible outcomes for each event, which are the jeans, the t-shirts, and the shoes. And this gives us 4 times 7 times 3, which is equal to 84 possible outcomes, and therefore there are 84 different outcomes. Now let's take a look at our third try question. We can use the quick method to answer this question. How many different outfits can you make from 4 t-shirts, 5 pairs of jeans, and 5 pairs of shoes?
So it will be your turn to answer and check if you understood this lesson or not. What is the probability of rolling a number greater than and flipping greater than 4 and flipping tails? So finding the probability of a compound event, what is the probability of rolling a number greater than 4 and flipping tails? So what we have to do at the beginning, you are going to express how many numbers greater than 4 in a die. So we have 1, 2, 3, 4, 5, and 6, and then we will write a coin. It will be heads and tails. At the beginning, we have to write all the possible outcomes. Like then we will write head and 1, 2 and heads, 2, 3 and heads, 4 and heads, and so on. So we will search about how many numbers greater than 4 and tails. So greater than 4 and tails. So we have 2. So probability of greater than 4 and tails, it will be equal to numbers, which is 5 and tail and 6 and tail. So it will be 2 out of 12, which means in simplest form, it will be 1 out of 6. So we write 2. This is the number which is more than 4 in the coin, sorry, in the die, and with tail. So it will be 1 over 6, and we can multiply it by 100. So we found it in percentage. Okay, what is the probability of running less than 5 and flipping hits? So we have to back to check. Try to do this by yourself. What is the probability of rolling less than 5 and flipping hits? So you have to concentrate with heads, and it should be less than 5. So how many times we have less than 5 and heads? So we have 1 and 2 and 3 and 4. So it will be 4 out of 12, which means it will be 1 out of 3, and then we can write it in a percentage form. Thank you for watching. This was our lesson today about how we can find probability by using different ways, by tables, by listing, and by a tree diagram.